Going to the right side now of our worksheet, a couple of more examples of kinds of things in sort of a formula form that we're going to be seeing in Chapter 3. We're calling this 7, and here we see slope of one equation is equal to the slope of another equation. But the y-intercepts of the equations are not the same. So here, when we see this and we're comparing the slopes are the same, but the y-intercepts are different. What kind of lines are these? And this is what this symbol shows for J. This L is indicate the lines are parallel. And what we are asking you to do here for letter K is just summarize this in a couple of short statements here. So, once again, when the slopes are equal, but the y-intercepts are not equal, the lines are parallel. So just put that in short phrases here. And we'll pause to let you do that. Now, as we look at example 8, again, we're dealing with the slope of one equation and the slope of a second equation. And we're doing what to them? Well, this indicates multiplication. If we multiply the two slopes, and the product of this multiplication is a -1, such as if the slope of the first equation was 1/2, and the slope of the second equation was a -2/1, in a sense it's negative reciprocal. Just flipping them over, when we do the multiplication, this all just cancels out. And we're left with just a -1. So when the products of the slopes, when the product of the slopes is a -1, such as we're showing here, then we say the lines are perpendicular. And I may have run out of room, but you have room. So again, put it in writing. We'll pause, take a moment. The product of the slopes of two equations is a -1. When this occurs, the lines are perpendicular. And that's the symbol for perpendicular right here. Upside down, capital T. Okay, we're going to raise it up a little bit. Now, example 9 is just a little exercise that we're going to do, that when we have a formula that's in standard form, and this is an example of it, we can use a special T-chart. Now we're calling this T-chart the X and Y intercept T-chart, because we are going to be plotting the intercepts. So as we see in this one, if we put a 0 here, and then in the next row down a 0 there, and then we put this value of 0 in this equation, 3 times 0 is 0, we get 4y equals 12. So we do our division here, and we get y would then be a 3. Now, if we put the 0 where the y is here, 4 times 0 is 0. We get 3x equals 12. Divide both sides by 3. X here will be a 4. Now, we had said, and just as a little review, that whenever you have an ordered pair with a 0 and some value for the y, this is the formal way to write the y-intercept. And when you have something that's an a, which is the x value, and this y value is 0, this is going to be your x-intercept. So, how do we graph this? Well, again, this is our y-intercept, 0, comma b. And this is going to be our x-intercept, a, comma 0. So 0, comma 3 is right there. And 4, comma 0 is going to be right there. So we then take our line tool. I think I just wiped all that out. So our graph then looks like this, where this point right here is where our graph crosses the y-axis. This is the y-intercept. And where our line crosses the x-axis, this is our x-intercept. So a good tool when you're plotting intercepts, that will be one of the questions they ask you in Math Lab. By finding the intercepts, draw the graph. Well, for this, again, I strongly advise using what I call the X and Y intercept T-chart, where there's a 0 there and a 0 there. This will be your y-intercept. This will be your x-intercept. So letter N is, what do we call this special T-chart? And we said it was the X and Y intercept T-chart. And I guess we could extend that a little bit like so. Alright, we're going on to our last item on this worksheet, and this will deal with some background information that we can use if an equation is in the slope-intercept form, as we see here. There is a special way we can use this formula to actually graph. And we're keeping in mind that whatever is the coefficient of the x, this was the slope, and what's ever in the b position, this is your y-intercept. And we are reminded that slope is rise over run, or y units over x units. So the first thing we do here is to plot the y-intercept. There's our y-intercept. And when you use MATLAB, you just put a dot on -2. So we know our line is going to cross at -2. And from that point, we plot the slope, 1 over 3. Now, there's different ways to do this. My suggestion is that if x and the value of the slope is positive, you're going to do the run first. So that means mentally you're going to go 3 units this way. And then that's what you do in MATLAB. You have a dot there, you move your line this way, and now how many units up do you go? Well, what are the y units here? 1. So you're going to go up 1, make your second dot there, and then the line forms. Now here I'm a little bit off. It should be right on that dot. But when you do it in MATLAB, you can do it very well. And of course, with the graphing stamps, you're getting some nice graphs to practice plotting using the slope-intercept form. Once again, you plot the y-intercept, and then from that, you then do your slope. And again, if it's positive, you're going to go over to the right and then up the number of rise units. Or if this were negative, you would go over this way and then up. Now, some have suggested they like to go up 1 first and then over 3. Perfectly fine. And remember, this is positive slope, and that's what we're showing here. All right, we'll wind this up.